Hello and greetings to everyone. This will be the last video of the second unit of our course on robotics and automation. Okay, the syllabus is as given by the SNS College of Technology, and it is basically intended for the aerospace engineering students of the third year. Now, let's continue with our class on the last video, as we said. The second unit syllabus has been shown here. In this particular video, we are going to look at more about the robo programming, etc. Although it is not there, we are covering it so that for the sake of completion. Now, the SCARA robot, this is to recollect the previous class what we have done. We had looked at the joint notation of the SCARA robo. How do we, how the various uh, robos are being uh, given a notation based on these symbols. Okay, that we saw. Now we'll move. Okay, there are various different kinds of joint drive systems: the electric system, the hydraulic system, and the pneumatic system. And basically, these are all for the making the movement of the robot. They use electric motors to actuate the individual joints. These joints, whatever we see here, these have to be moved. So for that, either you can use electrical, or you can use hydraulics, or you can use pneumatic also. The use of hydraulic pistons and rotary vane actuators, noted for their high power and lifting capability. The robots are sometimes used for lifting very heavy equipment. For that, the use of electric motors or drives, they use hydraulic drives. Pneumatic drives are also being used, typically limited to small robots and simple transform applications, because the amount of weight or the load that they can carry is limited. The robo control systems are quite simple. It's like simple pick and place kind of just pick a thing and then place it at some other place. Some other places or one type. Limited sequence control. Then you have the playback and the point to point control. It means you teach in and then it'll play back from point to point. The next one is playback with continuous path. Between point to point it is more likely for drilling operations, whereas for continuous path, if it is there, I can probably use it for welding operation where a seam weld could be done. Now, there is also something called as an intelligent robo. It exhibits behavior that makes it seem intelligent. That means responds to sensor inputs, makes decisions, communicates with human beings, etc. There. I would like to recollect the students to the type of teach-in robo that was used in the movie Titanic, when they went for underwater exploration of the sunk ship, or the Titanic, and then uh, from a different distance, he controls and then opens a cupboard and then tries to take out that notebook. Now that is something very similar. We are talking about the teaching robot. Then you also have the industrial robotic application, the various applications for the robots. Since we have come to the end of this unit, basically they are used for material handling, pick and place, palletizing, etc., where you can take the door of left front door of a car, and then get it welded and then place it into the car, that kind of movement. Or if you are putting it on a pallet, it really knows like what is the advancement of the next job it knows. That means if it has put in place A, the next time it will not put it again on place A. It will try to put it on place B, C, D, like that. It will, till the pallet is over, and then it understands. That means all these things it get indexed by that small distance, and then it moves on. There are for different kinds of processing operations, robots are also there. Like one is for welding. There are in welding, you can even use it for underwater welding also. Then you have spray coating. Spray coating, definitely robots are being used, because otherwise the spray vapor gets painted onto your nostrils, and then it is very harmful. So it's better to use the robots. Cutting operation where there is sparks or etc. comes up. There places where it's quite severe, where monotonous one, or it could be like something where precision is required. You can probably use robots there. Assembly and inspection, definitely. In assembly, more of taking of a component and then fitting into it with a different orientation, and then trying to place underneath or whatever it is. All these things can be done by the robo 24/7 without any fatigue and etc. there, as vis-a-vis to the human person. Inspection also could be done in a similar. The robo programming is of three types. One is the lead-through programming. Work cycle is taught to the robo by moving the manipulator to the required motion cycle and simultaneously entering the program into the controller memory for later. So I teach him the coordinates. Okay. So I walk the robot there and then say you have to move. This is point number one, point two, point three. Then the robo will follow the same track. Then you have the different robo programming languages, textual programming language to enter the commands into the robo controller. So simulation and offline programming. The program is prepared at a remote computer terminal and downloaded to robo controller for execution without need for lead through. Now this is very similar to the CNC machine. So if it has got a memory etc., then you can always use it to, you can write the program and then bring the program and then load it onto the robot. Now, in the lead-through programming, it is powered lead-through is there, and then the manual lead-through is there. Common for point-to-point robots, you uses teach pendant. You have a pendant, and then take the pendant around, and then teach this point and register the points, etc. The other one is the manual lead-through, convenient for continuous path robo, and then a human programmer physically moves a manipulator. This is what I had just there. What are the advantages? Easily learned by shop personnel. Logical way to teach a robo. No programming etc. happens because you physically move around and then register the points there. Then what are the disadvantages? The downtime is definitely very high. Then the limited programming and logic capability. It cannot take decisions. Not compatible with supervisory control. Okay, this I had included basically just to show you how simple and English-like programming motion commands are there. Like move to point P1 here at the point P1, use a lead or the thing. Then moves point 3. Then these kind of things, approach, depart, define, all these things. What is the speed that you have to move with, etc. All that is very English-like programs are there. More like our APT program. Automatically programmed tools that we learnt in the CNC machine, very similar to that. Now interlock and then sensor mechanism commands are there. You can wait for the signal, react to something, save, stop, etc. Or the gripper commands are there to open, close 25 mm. Means just that amount it is going to close. So that the other things we'll have to take care. Means if something is 26 mm, then we can put a rubber padding into the gripper, and then 25 mm if it closes, then it is going to hold it. Okay, so close with 2 Newton force, that is also given. So things are very simple, and once we get into the programming, it will be fun and then uh, quite exciting. Okay, so with this, we're just summarizing what we have done today. Like we had looked at the various joint drive systems, robo control systems, and the programming of robots, the teaching methods, etc. All that. Okay, so this completes the second unit. Uh, Videos on the second unit. We have made 5 videos on the first unit, 5 videos on the second unit. So we'll meet again on the third unit. Thank you very much. Um, we will close here. Thank you.